Hi everybody, John Accardo here. In this video, I'm going to show you how to test your clamp-on ultrasonic flow meter independent of your application, in the event you might be having problems getting it up and running. You've installed your clamp-on flow meter, but can't seem to get it to work. You are careful to follow all instructions for programming accurate pipe dimensions, use of coupling material, and proper installation of the sensors at the spacing indicated by your flow meter. But your flow meter won't measure flow. Instead, your receiver signal is just a flat line. Your flow indication and sonic velocity measurements are showing zero values. And you also notice some active maintenance alarms. The bottom line is you have no ultrasonic signal. In such cases, it's all too common to suspect the flow meter, yet more times than not, it isn't the meter. It's the application pipe or fluid that's to blame. So how can you troubleshoot the possible cause? In such situations where there are multiple potential sources for a problem, the best method is to separate the flow meter from the application by testing it independently. For liquid meters, using universal sensors, Siemens offers test blocks on which you can install your sensors. Alternatively, you can perform a face-to-face test. Both methods enable you to test the flow meter system independent of the pipe and liquid. For gas meters, you can perform an air test to isolate the meter from the pipe. These procedures are explained in separate videos. I've put links to them in the video description. However, the one caveat to performing these tests is you'll have to remove the flow sensors from the pipe. Yeah, this isn't always easy to do, or you just may not want to. Wouldn't it be nice to test the flow meter and sensors while they're still installed on the pipe, yet still achieve isolation of the meter from the application? Well, you can, and this video will explain how. Oh, and this procedure can be used not only on liquid meters, but also on gas meters, and not just on FS230 flow meters, but on every clamp-on flow meter Siemens has ever produced, including the FS220, plus all versions of the previous generation 1010 and FST020 flow meters. So let's get to work. First, the rules. In order to facilitate this test, your flow sensors must be installed in reflect mount and on a metallic pipe. When the sensors are in reflect mount, sonic energy is transferred into the pipe wall, which travels along the wall and is detected by the receiving sensor, as this animation illustrates. The fluid signal, the one that passes through the flow stream, arrives much later. This is the characteristic wide beam or Lamb wave signal we've pioneered. To demonstrate this, I've clamped a pair of sensors to a piece of steel plate at the appropriate spacing for a 6-inch pipe. I'll use a transmitter and an oscilloscope to view the ultrasonic signal propagating in the steel plate. And there it is. Out in the field, your pipe wall will perform the same function as the steel plate. And with some creative programming, which is the whole point of this video, you can make the flow meter see the ultrasonic energy induced into the pipe wall, just as we did in the steel plate. As we saw, the pipe wall signal travels much faster and a shorter distance than the fluid signal. Therefore, it arrives at the receive sensor first. The fluid signal travels a greater distance, arriving much later. Normally, the flow meter will ignore that early pipe wall signal by electronically blocking it from detection. It does so by positioning its detection or RX window where the theoretical fluid signal should arrive. This prevents detection of the pipe signal. Our goal is to get the meter to see the pipe signal because in our case, we don't have a fluid signal, which is likely the reason the flow meter isn't working. This is the creative programming I alluded to earlier and is very easily accomplished. I will outline the procedure for the liquid applications in this video. Gas applications are a bit trickier, so I will cover them in part 2. You can skip to that video now if you're working with a gas application. Okay, all you liquid application people. Let's assume our pipe is a 12-inch standard wall steel pipe flowing water. The theoretical transit time for a reflect mount sensor installation using D1 high precision sensors is 572 microseconds. This is how long it will take for the sonic beam to travel from one sensor to the other through the fluid, and how the meter will position the RX window. The pipe wall signal will of course arrive much earlier and be electronically blocked. To get the meter to see the pipe wall signal, we have to change where it's looking. So step 1, leave your flow sensors exactly where they are currently mounted in reflect mode at the correct spacing for your pipe size. Step 2, and again this is just for liquid applications, change your pipe diameter programming to half the current value. Thus our 12.75 inch outside diameter will now be changed to 6.375 inches. Why, you ask? Well, on a smaller diameter, the sonic beam takes less time to travel. Thus the theoretical transit time is now much smaller. Remember, the goal is to make the flow meter expect the signal to arrive much earlier than normal. Step 3. Do not change the wall thickness. Well, that's easy. Step 4. Change your mounting mode programming to direct. Wait, what? Yes, direct. Remember, the idea here is to get the meter to look for the sonic signal earlier. Direct further reduces the theoretical transit time. Now the signal is expected to arrive even earlier. This will further adjust where the meter will be looking, which should put our RX window in just the right place for the arrival of our pipe wall signal. Is this all very confusing? Well, don't worry. The steps we just covered gave a detailed look at the effect each of them provides. This was to help you understand why we're doing them. In the field, there's no need to worry about the whys. Just focus on the how. The procedure is always the same regardless of pipe size. For liquid applications, simply change the programming to half the pipe diameter and direct mounting. Then leave your sensors right where they were originally installed. That's all you need to do. And now we're ready to proceed. Just go ahead and complete the remainder of your programming steps so that the meter performs the frequency sweep to generate operation. You should now be able to see a receiver signal, which is kind of like the meter's heartbeat. The meter should exhibit proper diagnostic values for signal strength, and you should have a flow measurement which will be at or very close to 0. Achieving these results confirms your flow meter is 100% functional, since it is operating exactly as it would in a normal application, transmitting and receiving a sonic signal. You have verified the functionality of the electronics and also the sensors, the sensor coupling to the pipe, and the sensor cables. Successfully achieving operation as described further identifies that the meter's inability to measure on the fluid application is due to unacceptable application conditions, such as an empty pipe or partially filled pipe, a highly aerated liquid, a cavitating pump, or excessive fouling of the inner pipe wall. All of these conditions can potentially prevent the transmission of the sonic beam through the flow stream, and it is not a fault of the flow meter. Having separated the meter from the application and confirming its integrity, you can now look into taking corrective action to improve the application conditions, which will enable proper flow meter measurement. Siemens technical support is always available to assist with any questions you might have to sort this out. Once you've completed your testing and taken corrective action, be sure to reprogram the meter for the original pipe size and the sensor mounting mode. Thanks for your attention. I hope you find this helpful. This is John Accardo saying bye for now.
Siemens, ingenuity for life.